All right, we are in section 7.4 where we are going to look at special right triangles. So there are two theorems that we are going to use to help us find unknown lengths to certain right triangles. So what we're going to look at is we have a 45, 45, 90 triangle theorem and a 30, 60, 90 triangle theorem. So if you look at the first triangle that is illustrated to us, we have a 45, 45, 90. Anytime that we have a 45, 45, 90 right triangle, we know that it is also an isosceles triangle. So isosceles means we have two equal sides. In this case, it is x and x. Now what the theorem does is this. Those values of x are also going to be attached to the hypothesis, or hypotenuse, I'm sorry. And whatever value of x that happens to be, it's also going to be multiplied by the square root of 2. Okay? The next one here is we have a 30, 60, 90 triangle theorem. Now, if you look, the value that is the side length that is opposite of my 30-degree mark is our value of x. The hypotenuse is going to be 2 times whatever that value of x happens to be, and the opposite side of the 60-degree mark is whatever that side is times by the square root of 3. And um, we can use that to find any unknown values. So for example A we have here, what they tell us is the hypotenuse is 2 times by the square root of 2. They want us to find the value of x. Well, if you notice here, like in this one here is x times it by the square root of 2 when these are x. So if this portion right here is 2, that means that these two values here are also a value of 2. When we look at this one here, I got square root of 2 and square root of 2 are my two leg lengths. So those are like, these are my value of x, this is my value of x. And then this right here is x times by square root of 2. Well, they're telling you that this x is square root of 2 right here, so y is going to be the square root of 2 times it by the square root of 2. Square root of 2 times by square root of 2 equals square root of 4, which is 2. Looking at these examples here, I know that because it's 60 degrees right here, I know that this is going to be uh, 30 degrees. And I always said that whatever the value of opposite is, like that value of x, that's what it is right here. The opposite value here is going to equal 2 times whatever this value is, and so in this case it's 2 times x. This value right here, they're telling you that this is going to equal x times it by the square root of 3. So that means here, in order for us to find x, I got to divide both sides by square root of 3. So to find x, I take 9 divided by the square root of 3, and that equals roughly 5.2. We'll just round to the nearest tenth. And then over here, to find y, it's going to be 2 times 5.2. So 5.2 times it by 2, that means y is going to equal 10.4. And one of the advantages here is you can always check these unknown lengths with a applying it to the Pythagorean theorem to make sure it makes sense. So, so yeah, I just checked mine. It seems to work out. So here we have another 30, 60, 90 right triangle. And then, so 30 here, that equals x from the formula. This here is going to equal 2 times x. And then again, this right here is going to equal x times it by square root of 3. So again, we can go over here, take 15 divided by the square root of 3. That means that x in this case is going to equal, I would say, roughly 8.7. And then over here, it's going to be 2 times it by 8.7. So 2 times 8.7 is going to equal 17.4. And again, you can check that with the Pythagorean theorem to make sure it makes sense. All right, so sometimes you're going to be given different shapes, but you could probably use these special right triangles to help us figure it out. What I'm going to do here is make a dashed line, put it at 90 degrees. So I basically have a triangle here and a triangle here. So this is 9, this is 12. With that being said, this is a 45-degree angle. And because it's a 45-degree angle, I also know that the distance from here to here also needs to be 12. So I can find t because the distance from here to here is 9. The distance from here to here is 12. 9 plus 12 gives us 21. So t equals 21. All right, so because this is a 45, 45, 90, I can say that, ooh, this is x, this is x, this is going to equal x times by the square root of 2. Well, x is 12, so y is going to be 12 times by the square root of 2. Looking at this last value here, it seems like they gave us an exterior angle. We know that we have a linear pair in this case, so 180 minus 135. This gives us 45. So makes sense that these two are the same length because this is a 45, 45, 90. I look here, this is going to equal x times by the square root of 2 from the formula. These values equal x. Well, x in this case is going to equal 8. And that is being able to use special right triangles. Hope this helps. Until next time.